Hello, I'm Paul Brook. I work for Dell Technologies and I run a team of specialists who look at artificial intelligence and software, we call it Native Edge, that helps you manage and orchestrate all of that AI and data that's going to be created at the edge of organizations. Key elements of the presentation are really vital that you engage. Always assume somebody needs to hear about what AI can do for their organization. Second point is, don't pick a project where you don't really understand the process that arrives at the outcome. AI is not going to fix a lack of understanding of process. The opposite is true. If you really understand the process, AI will probably deliver value, and it'll automate to either save or make money or engage with citizens. And the third point, again and again, it takes a community to deliver an effective AI outcome, including everyone at the customer's place and everyone in the customer. It is about delivering together. This is not a solo sport. I'm going to talk a bit about high performance computing. I manage a team of folks that have worked in that space for a long time. Indeed, I've worked in that space for a long time. But I'm also going to talk about some AI use cases, and I'll sprinkle in that some of the things that you as folks who are running IT operations probably need to sort of soak in. And then I'm going to finish with a piece about just how crazy it's getting. So I want you to remember high performance computing, supercomputing, right? And you're sitting there thinking, is not me. Okay. Now we've been doing this a while, and we've been doing this. You have to turn it on, you see. Did I say I've been doing high performance computing for a while? Windows, not comfortable in it. That's my get out of jail card, right there, right there. Linux, super happy. Look, we do go back a long time. I'm now in a wonderful place where a guy who I call a friend, and we all know what it's like at work, that kind of, you work with people, they become friends, they retire, you keep in touch with them. Way back down this journey, 1999, specified what Dell Technologies in Europe, Middle East, Africa identify as the first high-performance cluster based on a technology called the Beowulf cluster that had been built by the academics, and it was the first system that joined together lots of machines and made them look like one. You're thinking that's the opposite of VMware. Yes, it is, isn't it? It was done with PlayStations, actually, so you can kind of put when that is. So it started on Linux and multi-core, way back. Steve Smith was putting that system into CERN in 1999. And for those of you that follow pure physics research, you'll go, well, hang on a minute. CERN wasn't operating in 1999. Not true. CERN wasn't operating the experiments back then, but they were getting ready. So what they were actually doing was building software that they'd need to use. And that becomes critical as I finish up with AI. So bear that in mind. Now, look, there's some familiar names, and of course we're going to put stuff on this that make people go, oh, I know them, McLaren. I always do, hands up, who owns a McLaren? It's pushchair for the kids, really. What were you thinking? Different McLaren, obviously. And you can see Jerusalem, and we've got Jaguar Land Rover, hands up, who's got a Jaguar or a Land Rover? Yeah, well done. I've had a few in my life, and there's that moment where you sit with a wonderful customer going like, I'm sorry I'm late, and they look at you and go, don't say it. Don't say it. So you also see at the top lots and lots of commercial companies and names like Stampede. You see the Frontera systems. These are big systems. These are the supercomputers. The largest one in in UK at the moment was announced when, Sunak and Musk were sitting on a stage and you were trying to think which one of them owns the most of the UK. Tough world, isn't it? This was announced, Dawn, at University of Cambridge. Really interesting project. University of Bristol have also got some funding. You'll see them making some announcements with our competition, but that's okay. This is pure research. This is the first time you see AI and HPC appearing on press releases. Now we know in the background there's been a lot of work, and keep that thought, not me. You're not going to buy a supercomputer. You might want to. Oh, really, fill your boots if you do. Hello, I'll come back to that. What is interesting is two things. We're in a hybrid world now. First thing that's interesting is this is hybrid. So you've got core HPC. You drive a Jaguar have to design a Jaguar. They use computational fluid dynamics to look at the way the air flows across that, so it's more efficient for fuel. McLaren Racing does the same, so it sticks, wins races, etc. Core, well understood physics. AI might be well understood in some ways, but it uses a different computational platform. We're all familiar with the GPU, or accelerated computing. There's a hybrid system in the Dawn system, so they can run both. It's now very rare for a professor to turn up and say, I want the whole system. So let's carve it up. They're delivering a service for research. Here's the first free gift to you. And sorry, Access, I really, if you want to play on this, for a small fee, Cambridge will let you. Or collaborate. Doesn't matter what business you're in, public sector, private sector, for-profit, not-for-profit, doesn't matter. Getting access to supercomputers, the reason they got money was to allow access. So folks who have a really great idea can maybe try at scale, can play with it, can use PhD students' brains, and sponsor a PhD student if that's in your gift. We encourage everyone, talk to Access, talk to Dell. We'll put you in touch with Dr. Paul Collegiate at Cambridge University. We were with him last week, and they will facilitate, through an approved process, a way to either fund it or you directly fund it. Take advantage of that. Bristol will have the same. You'll see Edinburgh doing the same. This is the future, public research partnership. Never forget that. Never forget that. These are not now built for the benefit of someone else in academia. Now, I want to briefly look at what Dell Technologies do. And thanks, Ricky, a brilliant summary of the servers, the storage, the hyperconverged. I'm just really stacking up from this because as you look at what's described there as a platform with model augmentation, hands at anyone who knows what that means. Right. Oh, come on, Ricky. I was waiting there, thank you. I counter this, and we were actually talking about this before we started. Model augmentation, fine-tuning, model training. These are data science terms that are drifting into IT and some cases business. I wouldn't beat yourself up. I'd learn it, get to know it, but don't beat yourself up if you're not familiar with it like that straight away. I always use this one, so forgive me. Folks who've heard it, please don't shout. What do you call someone who kind of understands all of that, understands AI technology, and really gets the use cases and the business applications? There's a collective noun we use. They understand the business use and they understand the technology. What do we call them? Call them billionaires. Don't beat yourself up. That's quite a small crowd. But actually, it's important to understand you do need a crowd for this. It's the first thing we say to everyone. You need, it's not tennis anymore. And if you're delivering a service to your organization, it becomes really important to understand this is like US football. There'll be a point where you go, as the leader of the team, and maybe the CFO will come to you, the chief finance officer, go, think of you, anyone familiar with US football, American football? You're kind of seeing, you're aware of it. You get the CFO going, hang on a minute, I pay someone a bunch of money to be an elite athlete, and their one job is to catch a ball and hold it so someone can kick it. And I go, yes, says the special teams coach. And I go, what do they do? So if they don't hold it right, the kicker, and that's all the kicker does. There's a clue in the name. Can't kick the ball over the post. Yeah. And win the Super Bowl. And then a smart coach goes, 19 of the last 23 Super Bowls have been won in the final kick of the game. Now, do you want to fire that person? Put them on the coaching roster. Get me a backup. That is what AI means. If you want to do natural language search, content, if you want to do that, you're going to need the equivalent of someone who just holds the ball. Now, you might not need them on the payroll, but it's important to start the process, particularly with senior leadership, going, it's not a village. This is not a small town. This is London, New York, Paris, Munich. Everybody talk about pop music. You go, oh, come on, let me have that. It's Pavlovian. I'm going to give you something that I want you to work with Access. It's very important because we use your data as your differentiator. People often go, oh, it's a bit self-serving because we know that Dell Technologies stores something like 50% of all enterprise data. At which point you go, I did not know that. The source is IDC and Gartner and many things. Actually, for AI and increasingly for things we're seeing with high-performance computing, the input data becomes critically important. And the analogy I use is like hiring someone. And you can hire someone out of Cambridge University, they've got a PhD, they're a former professor, brilliant, what a mind. Drop them in front of the desk and they're like, well, what do I do? Yeah. You never say to a PhD to figure it out. But aren't you going to train me in like where the front door is, where the canteen is? At what point does that smart person become your smart person? Institutionally yours. For those woke folks that say, they'll never be yours. Indeed. And it's because you, in effect, put data in there. Now, I am not anthropomorphizing, really not easy for me to say, AI. But the analogy stands. Putting your data into an AI makes it your AI. So when you bring your AI to the data, what you're starting to do is do that fine-tuning. It's making what you want it to do for you, not for everyone. Is anyone familiar with the Asimov model that, not the author, the Asimov model that NVIDIA have built? It's a pre-trained model. Does anyone want to shout out what you think the Asimov model is pre-trained to fundamentally deliver? If I say robotics, those that are in their sci-fi will go, yeah, Asimov did iRobot, and that became the film. So it just tells you a lot more about people from NVIDIA than it does any other piece of information I'm going to give you. A lot of developers there. The Asimov model, one of the things they used to train it was synthetic data. And they used an old hockey game, but really boiled down to its essence of a player hitting a ball. But it looks like Minecraft for those of you that are familiar with it. You don't need rich data. What you need is specific and accurate data. You then fine-tune the robot to operate in your warehouse or in your hospital or on your routes. We've got robots in our factory in Cork that literally, they take memory DIMMs that go in high-end storage that cost more money than I'll ever see in my life. And you carefully place these in the robot and it goes off to where it needs to be. And it's anti-static, anti-collision, everything. We used to, seriously, it was like a waiter, a tray with rubber mats and all that. And if you ever think of a factory, this is the opposite. This was walked down with two people on either side. It was so expensive. If you've ever been in a fab plant where Siemens or Intel, you get the same thing with the wafer. It's like, this is a lot of cash. All of that is about the data being used to train the robot in the factory. And this is the gift. And please, will it? Yeah, let me. Christian Spindelware built this for me. I wonder if it's going to go on now. Yes, this is the last phase of a workshop that whiteboards out what many people are asking us about. Many people are asking Access about it. How do I deal with data where it's all over the place? And I'm sorry, because 15 years ago, we were saying, build a data lake. Build a single source of truth. How did that work out? I am sorry. We weren't wrong. We were catastrophically wrong. It led a lot of people astray. Gartner are now going data lakehouse, and we start with that. As we advance, what we're saying is single source of truth, rather like the real world that data often imitates, is incredibly biased. The single source of truth for the person running the depot of an ambulance service might be incredibly different from the single source of truth that the Chief Executive Officer looks at when they look at the map on the wall. I got 500 ambulances ready to go. And the people in the depot go, and you can't, which is the truth. Both is true. Whiteboarding's a workshop. It helps everyone in this room start to go, where is my data? What do I think it is? How do I build, you see, data products that start to feed systems I can automate? And automation eventually is an AI function. It's an AI function because you're building intelligence into processes that you understand. And here's the second free thing. I know you charge millions for this, but I'm going to give it away. If you're going to take an AI project, don't pick something that you're really bad at. Because, does anyone play a musical instrument? If you imagine being a drummer. Okay, I did say musical instrument and then talked about drums, so I'm sorry. I know. So imagine playing drums and then going into a recording studio. Ask yourself, will the recording studio expose a bad drummer? Well, yes, it will. If you pick a process that you don't understand and then inject a lot of advanced algorithms and a lot of advanced maths to automate a process you don't understand, why do you think that'll make anything better? In the same way a bad drummer goes in the studio and thinks, hang on, everyone can actually hear me playing out of time, and all I need now is software to fix it. There is software to fix a bad process, but you still need to understand the process to know where it's bad. So pick something you're good at, pick something you have good data for, and then start the project. Is that okay? Now, I'm going to give you an example. Everyone in this room should be excited by this. This is not a supercomputer. This is all sorts of phrases for that. This is the city of Amarillo, the face of the city of Amarillo. Does anyone in the room speak any Spanish at all? A little bit. Yeah. I had my stag do in Spain, ocho cerveza, ocho. There's how many of you? Everyone here. Cerveza, really? The point of asking about Spanish is Amarillo has a huge Spanish-speaking population. And what the mayor basically said was, we need to deliver services. I got banks where you can go on an app and you can get a loan. You come to the city of Amarillo and say, where's the library? Where's the police station? Where's the mayor's office? And if you don't speak English as your first and prime language, that can be difficult. Surely we could use AI. And we've got a demo with a mini AI that operates at the edge. I'm going to say, Alexa! Doors are really good. I love doing that on Teams and watching people say, don't say that. Alexa, order Land Rover clips. Don't say that. If you can do this with Alexa, can we build on a screen a digital image, the face of Amarillo, where if you approach the screen, remember, laws are different. You approach the screen, it looks at you, it recognizes you, it puts up an image that you were happy to interact with. And there was a lot of choosing of the image, but it does change. It then responds to the language that you spoke to it in. Now you're going, it's just a chatbot. Oh, really? Really now? Really? That's like saying that's an abacus. It's identical to the Dawn supercomputer. It's not. It's super advanced. Chatbot might not respond in that language. Chatbot might not react. Facial expressions change. The lips are synced to the speech. I want, as we announce this next month, you to speak to Access. I want to speak to your guys. I want to work this through. I want this in every place in Britain where there are not enough translators, where there are not enough guides. Can you imagine walking into, and I'm going to pick on a big hospital because I'm at Reading and the Royal Berks is undergoing some construction. So you come in and you go, where's the cancer treatment space? Now, if you're asking that question, you may be under some pressure. So you're looking for the signs, and it's follow the red line, but there's a big wall there, just like there is here. I'm now under a lot more pressure. My user experience has changed. Why not be greeted by a Paul? Obviously with much better hair, like this, none, that simply says, you're looking for the cancer room, how do you know? Because I heard you talking to your other person about cancer treatment, just in case there's a diversion, but if you follow the green dots, and occasionally you'll see a green sign saying cancer outpatients. Is that any help? Well, no, actually, I was looking for where I can park so I can, sorry, that's the conversation it will have with me. Don't need to pay a medical member of staff to do that. In fact, if any of you work in the NHS, and I say, why don't we just pay medical staff to do that? You will get the chief clinician looking at you going, I tell you what, why don't we pay medical staff to make sandwiches? Right people, right place. This is Edge. The screen has a PC in it to allow all that to happen. You train the machine in a system. You then adapt as the machine gets lots and lots and lots of inputs. You save that data and you recalibrate the machine. Maybe Spanish isn't the biggest language. Maybe it's Urdu. Maybe it's American English. Has anyone, I'm not going to say it, has anyone been to Amarillo? Clearly you know the way, but has anyone been to Amarillo? Not putting that in your head. Peter Kay will be sitting there going, I got you. You're sitting there going, it's North America, it's Amarillo, 2 billion people sitting in the city, paying their taxes, they can afford anything. 200,000 people are citizens of the great town of Amarillo in Texas. And no, I don't know the way. But this is what AI looks like when it's delivering value. I want to show you another one. Again, North America. You're asking, why North America? Because it's safe. If I talked about West Sussex, if I talked about Cornwall, you'd be going, how are they doing it? And they haven't talked to me about it. So I like to keep North America, it's nice and safe. Now, we know the founder of Duos Tech. We're speaking with them regularly, meeting with them next month, that they are actively looking at coming to Europe, Middle East, Africa. They do rail car inspection. They build that. Next to that, there's a small amount of VX rail and stuff that's off picture. And I'm guessing many of you have been to the States, as a high-speed train. Now, I presented this in France, and they fell about laughing at that phrase, right? You know, because if you've seen a US train, it crawls through, and it's about 2 miles long. And a high-speed French train, we're going to go, boom, whoa. Actually, at 160 kilometers an hour, they can still take telemetry as it drives through that. They call it an artificial tunnel. And because I am who I am, I go, but all tunnels are artificial. And they're like, yeah, I know. They kind of, I get the founder looking at me, go, you want to work with us, right? It uses not just cameras, but LiDAR and radar, all sorts of things, to inspect everything on the train as it goes through. Now, there's pre-designed inspections, but the example I get is brilliant. There's a bolt on boxcar 12, wheel 3 on bogie number 2 that's gone. It needs to be refitted. 7 to 15 hours later, that data is in a manifest. So the inspection teams that work for the US railroads, do safety for Amtrak, etc., know they go straight there with a bolt and a bolt thing, and they fix it. So there is not a train wreck. I know, it is, well, it's science fiction. It really is. Duos Tech don't do this, Dell does, and we work with the rail trail. We say, all that data, don't throw it away. Because what happens if it's always bolt through? Always. What is going on? Go to Cambridge and find out. Or just go, actually, do we need 17 bolts on a wheel? Go to Cambridge and find out. Model it, build a digital twin. But take real world data to do it with. And the real world data is coming in every time a train goes through this. Presented this to someone from the Middle East. Their minister's big problem, and this is not a British problem, but it kind of could be, was paraphrased by the equivalent of a permanent secretary. We're sick and tired of vehicles coming in from a particular place that are not fit for purpose. They break down on the road, they're overloaded, the drivers aren't trained. God damn it, we think 90% of them are drunk. And we can't stop them. So we showed them this. He said, see, I can stop them if their tires are worn. I can stop them if bolt number 12 is missing from the wheel. I can stop them if it's overloaded, but I can weigh it without having a weigh bridge that costs so much given the land points of entry. Oh, I'll ask them, they can do it. But I can guarantee you Volvo are already doing that for repairs. They now can control, using current legal precedent, access into their country, saying, I'm sorry, the vehicle is not fit for our road. You need Form D1119612B16, and you need to file it in these 3 languages. Or you can load it onto that truck over there. Brilliant. These are ideas and concepts. Make them your own. We know the people with access who can deliver this and deliver it as a technical solution for the real world. Make sense? I just want to finish with the supercomputer thing. Okay, there is our founder and chief executive, Michael Dell, looking very happy because another multi-billionaire, Jensen Huang, really nice guy. Later, I'll tell you a story about him and you'll go, oh, it's quite heartwarming actually. Really nice guy. Called out at the GTC event this spring, exactly what it says on the slide. Now, that is what I believe is called a ringing endorsement. But in actual fact, he says they're at scale, and scale is relative. What Duo's tech do is at scale, but it's spread across North America, including Canada. See what I did there? Yes, we're an American company, including Canada. When did we annex Canada? Oh, please, not now. It's on tape as well. I'm sorry, that was a joke. That was a Saturday Night Live joke for the benefit. Now, why is this important? At GTC, the Blackwell compute node was announced. Now, this will probably be next year. Terms and conditions apply. You will see that there's multiple CPUs and GPUs. They'll also likely, as we make a Blackwell machine at Dell Technologies, remember Michael Dell's the place to go to, have DPUs in, and DPUs will access a lot of the mechanics you need per box to run all these processes. So you've got multiple systems inside the system, which is what the Chinese had. National University of Defense, the #1 system in the world. You can see that there, November 2014. Conveniently, just under 10 years ago. So China and the US were in a bit of a compute arms race. That's a term that regularly gets used by the top 500. And they use an agreed system to benchmark the performance of supercomputers. And then they go, oh, you're the biggest, hey! And everyone gets prizes all around. It's announced twice a year because the world moves pretty quickly in this space. I want you to pay attention to, that's great on a LED, 33.86 petaflops. Do you care? Go with me on this. Yeah. It's a lot. It's a lot, pretty fast. It's a lot. It's a system of measurement to churn through processing power. That was the biggest in the world. Now, behind that little wrapper is something approaching 10,000 servers, nodes, and there's multiple wrappers, lots of networking, lots of storage to feed a beastie like that. You got it. You're remembering 33.36 and you're remembering about 10,000 nodes. Let's look at Blackwell again, shall we? Twice the performance. Now, by my reckoning, it'll be about 10 years when you'll be able to buy that. You'll have gone in 10 years from the world's #1 supercomputer to something twice as fast that you can put in a machine that will simultaneously translate language, will respond to emotional input, facial expressions, may even render, if you choose, if I am dressed a certain way, it can decide I will render someone dressed that way to make the person addressing the screen feel comfortable. Yes. And they say there's no such thing as progress. That is why all this compute power is needed. Now, interestingly, somewhere up here, you look carefully, it says liquid cooled. So you're going to put a supercomputer into a fundamentally retail, I mean by retail, point of contact between the citizen, the customer, the subject, the prisoner, whatever it might be, and they may all be the same person. And you're going to then liquid cool the supercomputer to give them a really interactive experience this time next year. So, what I leave you with, for the love of Freddie Mercury, talk to us, because you're looking at that going, actually, there's people in my org would respond to that sort of digital human. Actually, I've now realized just how much stuff we'll need to think about. But I can't get enough translators into my org when I get multilingual. This is the only way you can fix it. Now, you might not need to buy one of these. Remember, Amarillo are doing it now, and this isn't available now. So again, talk to us, right size what you need to do. Take advantage of supercomputers when you need them, but you know what? You don't need to buy them when someone else has already built one using your tax dollars, tax pounds, tax euros, whatever. But you can leverage that, access that, and work with communities to deliver back what your team needs. And it might be quite game-changing for an individual. Now, I haven't gone into all the groovy, funky things we do in the medical industry, blah, 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 blah. I just wanted to leave you with, why would you come to us? And it sums all of these up. It's de-risk. It's the right innovation investment, giving you security at the edge. If I tell you we have machines that you saw Ricky talk about that build into the factory a zero trust protocol. From the day you get that machine and it boots up and goes, yes, I am what I think you are, to the day you pull it off the network and say, you are done now, Dell take it back and repurpose it. Oh yes. The zero trust will be consistent. Really important when you're putting that in a hospital, in a prison, whatever. That it's tailored for your business is mostly about the data, but again, right-sizing this and that range of solutions. Without people like Access, we couldn't offer that range. I got to tell you, we say this regularly to our partners. Yeah, we make stuff, you turn that into experiences. So thanks for the sort of 15, 20 minutes. I've probably overrun, but hey, I've reserved the right to do that. Thank you very much. I am here till 3, so please pick my brains. That's what the session's about, but thank you very much.